Today we are discussing about the anti-lock braking system. For successful operation of the vehicle, brakes relies on certain level of friction. That is, there should be some friction between the tire and the road surface. That is, there should be some friction should be there. Then only if you are applying brake, there will be efficient braking will be possible. If the level of friction between the tire and road interface is insufficient during braking, then brake cannot be transmitted and braking efficiency is reduced. So, we cannot get an efficient braking if there is insufficient friction between tire and road. If you are applying the brake suddenly, what will happen if you are moving in a vehicle without ABS? What will happen is the wheels will go to a sudden locking, and because of that there will be a slippage in the road. That is, we will not get control of the vehicle, and it may create wear and tear, and it may create accident. That kind of things are possible. So, this is a case of a vehicle without ABS. That is, there is a slippage. There is a slippage of the tire between tire and road, and you can see how the back wheels and front wheels are moving. Front wheel is moving in one direction and the back wheel is moving in another direction. So, it may create accidents. When a tire is rolling, when a tire is rotating, the velocity between the bottom of the tire and the road should be always 0. That is, it is rotating. It has got a rotatory motion, but always with respect to the ground or road, the tire will have a velocity that is equal to 0. When a tire is rotating, in this direction, it will have a rotatory motion as well as a translation motion in this direction. It has got both two kinds of motion. One is a translation motion in this direction, and a rotational motion is there. Here you can see the translation motion and the rotation motion. That is, there is a forward motion. This is the translation motion. This is the rotation motion. At the contact point between road and tire, the velocity should be 0. The velocity at the contact point of the road and tire, the velocity between tire and road should be 0. But if there is some velocity, that will cause a friction, and it causes a slippage. If there is a motion between tire and road, then it will cause a slippage. All the four wheels, that is, this is the four wheels of a car. We know there will be a differential will be there if it is rotating in one direction. If it is rotating in another direction, one will have higher speed. Or if it is moving in forward direction, suppose it is moving in the forward direction, all the four wheels should be rolling at all times. That is, if it is forward direction, all the wheels should have same speed. But if it is turning, if it is taking a turn, then also the tire should rotate. If it is locked, if the tire is locked due to some action, there will be slippage and there can be accidents. That is, only a moving tire can be controlled. Only a rotating tire can be controlled. Without a rotation, we cannot control. We will not get any control over the tire or vehicle. Consider a movement. The car was moving in this direction. Suddenly, the drivers take a left turn. So, at that time, there was a translation velocity in this direction, but the rotation velocity is in this direction. So, there can be a possibility of slippage. The rotation velocity is in this direction and the translation velocity is in this direction. So, what will happen? There can be a possibility of the slippage. Now, there is a velocity between tire and road. Consider this case. Here the tire is rotating in here also the tire is rotating in this direction, left direction. Tire is rotating in the left direction. but the translation velocity is changed to this. Translation velocity is changed to this. So back tire is moving in this direction, and front tire will rotate first by applying by turning the steering. The front tire will rotate first, then after that the back tire will rotate. So here you can see both translation rotation as well as rotational motion has got same direction. Translation motion as well as as rotational velocity will be in the same line. It is not in the different line. So it will not make any problem. This kind of rotation will not make any problem. But the previous thing, this can make an accident. This can make an accident. So here it will not make any problem. So this kind of thing will happen due to the sudden stoppage or sudden braking of the tire or sudden locking of the tire. Tire will come to a stationary. So in that case only this kind of things will happen. Otherwise we can have a rotation like this. To avoid a sudden stoppage of the tire, to avoid a sudden stoppage or sudden braking of the tire, what we have to do is with some drivers, if there is no ABS, some drivers will pump the brake, it will on and off the brake. So in that case the tire will not come to a rest suddenly. He will turn on and apply and release the brakes. But here if there is ABS, that action will be done by the ABS system. That is, it will detect a stoppage of the tire. If the rotation velocity is come to 0, ABS will automatically releases the tire or the braking system, and again it will apply the brake and till the vehicle come to rest, the ABS will apply the braking intermittently. That is actually the functioning of the ABS. So here you can see in the write up, you can see most drivers cannot judge the point at which the wheels lock. That is, wheel may lock, but the driver may not be know about when it will lock. So what he will do is, normally if the car is without ABS, he will pump. That is, he will push and release the brake intermittently. That action is done by the ABS. That action will be done by the ABS. That is, ABS what actually doing is the pressing and releasing of the brake. That is, it will do it for 10 times per second. It will apply the brake, release the brake. So that action will happen 10 times in a second. So the tire will not come to a lock. An additional complication is that the friction coefficient at each wheel could be different, and the driver cannot break the force at each wheel individually. A driver cannot control the braking force in each wheel individually. When the wheel skid, the driver has very little control on the directional stability of the vehicle and therefore the probability of an accident. That is, if the wheels are skidding, the driver will not get any control over the vehicle. That is, here we have seen, here the tire is skidding, the vehicle is skidding. So even if the driver tries to rotate the steering, he cannot judge in which direction the vehicle will go. So in that case it may come to an accident. So what we have to do is, there should be a rotational motion for the tire always. The ABS detects if any of the wheels are about to lock. That is, ABS is detecting whether any of the wheels are locking and regulates the brake pressure at that wheels to prevent this. That is, normally in an ABS system we are using hydraulic braking, or in almost all vehicles we are using hydraulic braking. So we are applying this, we are changing this hydraulic pressure. So as a result, maximum braking force can be transmitted and the driver can retain control of the vehicle. That is, if you are having ABS, the driver has got the control over the vehicle. And the ABS components, the components of an ABS are wheel speed sensors. That is, we should sense the speed of the wheel. That is, the wheel speed should be sensed. If it is 0, at that time we should apply the ABS. Then an electronic control unit is there. That is, the sensor signal will be given to the ECU. The output of the sensor will come to the ECU, and there will be a hydraulic modulator or a hydraulic actuator is there. So this will apply the brake mechanism to the tire or wheel. This will apply from the output of the hydraulic modulator or hydraulic mechanism. The power will be transmitted to the wheel. In the previous slide, we have seen that there was a speed sensor in the wheel. So this is the speed sensor. That is, this is a tone ring. That is some toothed. This is a toothed wheel, and there is an optical sensor is also there. So because of this optical sensor, we can detect how many times it will cut the signal, or it can be a a Hall effect sensor also. It can be a Hall effect sensor, no, it is always it will be a non-contact sensor. Then we can detect whether the speed of the wheel is 0 or not. Then only we can apply the ABS. So the speed of the wheel has to be sensed. So in each wheel, if it is a 4-wheel car, in each wheel there should be ABS. Or if it is ABS, if we are using ABS in 4 wheels, in all 4 wheels we have to this kind of speed sensing mechanism should be there. And if we are using in 2 wheels only, then in that wheel we have to apply this speed sensing mechanism. Now we can see what are the consequences of wheel locking. That is, it will take more distance to stop the car. If the wheel is locked, it will take more distance. Even if it is wheel is stopped, there may be a translation motion. There may be a translation motion for the vehicle, and because of that translation motion, it will take a longer time to stop the vehicle. Then no lateral guidance. That is, if we have to direct the vehicle to left or right, if we have to turn the vehicle to left after applying the brake, and if the wheel is on lock, we will not get any control over the vehicle. Then abnormal tire wear that we have seen in the initial slide, then increased risk of accident. So these are the consequences of wheel locking, and if you are using ABS, all these effects can be reduced. So suppose we are applying, suppose the wheel is rotating in this direction, and we are applying the brake at this point, and at this point the tire starts to lock. That is, from here there can be a slippage from B to C, not from B to C, from this point to this point there can be a slippage, and the vehicle comes to stop at this point. So the total distance is C, the actual distance to stop. C is the actual distance to stop the vehicle. A is the distance without slip. That is, here the tire is rotating. From here to here the tire is rotating. From here to here tire come to a lock. Tire is not rotating. So there is a slippage, and there is a term called a slip rate. If the slip rate is equal to vehicle speed minus wheel speed, that is, vehicle speed is actually the translational speed minus wheel speed by vehicle speed. That is, if the vehicle speed is higher, from this equation itself you can see that if the vehicle speed is higher, the possibility of slip is higher. So as speed increases, the slippage also increases. So if the slippage increases, there is a possibility of accident. If the slip rate is reduces, the possibility of accident also will reduces. That is why everybody is warned about overspeed. If the speed is higher, there can be a possibility of slip, and there is a possibility of accident. Now we can see the functions of the ABS. That is, ABS will prevent the wheels from locking up. It will prevent the wheels from locking up, and it will avoid unconditional skidding. That is, it will prevent the unconditional skidding that we have seen in the first slide. The tire has got a skidding, and there has got a wear and tear in the road. Then enable safe braking. It will enable a safe braking, and again maintain steerability. That is, we can have good control over the vehicle, and again decrease stopping distance. Stopping distance will reduce even if we are applying brake intermittently. That is, we are applying a pulsed brake. We are applying a pulsed brake like PWM. We are applying brake on and off. We are applying the brake on and off due to this ABS, and even with that we have the vehicle can come to stop with a lesser distance. So these are the parts of an ABS. This is the ABS layout. So here this is the ABS mechanism. This is the ABS mechanism. Here this is the brake pedal. One is the brake pedal. This is the brake booster. This is a pneumatic actuator. A brake booster is a pneumatic actuator, not hydraulic. Again, from here hydraulic system will start. That is the master cylinder. 3 is the master cylinder, then 4 is a reservoir. So here you can, if you are if you are opening the bonnet in the car, what you can see is you can see an oil container, brake oil container. Here we will fill the brake oil. We will fill the brake oil in this point. Similarly, there will be a can for coolant also. There will be a can for the coolant. There will be a can for oil reservoir, and there will be a container for coolant also. Both are similar. And here all these are the hydraulic lines, and here is the speed sensor. 8 is the speed sensor, wheel speed sensor, and this is the disc brake mechanism. 7 is the disc brake mechanism actually. So in each wheel there should be speed sensor should be there. In each wheel there should be, here also 7 is there, here also 7 is there, here is 8, here is also 8, that is speed sensor. 7 is brake mechanism. Here also, in this also brake mechanism. Here also 7 and 8 are there in all 4 wheels, you can see. So brake shoe and it is actually brake caliper. It is actually brake caliper, and again there will be a speed sensor mechanism is also there. So this is the simple block diagram of our ABS control system, and it is ABS is a better examples of a closed loop control system. It is a very good example of a closed loop control system. That is, it is sensing the speed and applying the, if the tire is come to rest, it will release the brake, and if till the vehicle come to rest, it will do it automatically. So it is a good example for automatic control system. So there is a monitoring system, that is the speed. This is connected to the wheel. This is connected to the wheel. Sorry, here the speed is sensed. The speed is sensed from here, and here the brake is applied. The brake is applied here. So speed is sensed. So there will be a hydraulic unit, control unit. Then again this is an ECU, electronic controller unit. This is an electronic controller unit, and this is the hydraulic modulator. This is hydraulic modulator. This is the hydraulic modulator. This entire thing is electronic control unit. It will monitors the speed of the wheel, again other parameters, whether you have applied brake. This we have to check whether you have applied brake. This has to work only when ABS has to work only when you have applied the brake, and at the same time tire come to rest. If the tire is not in rest, if the tire is not come to lock, ABS should not work. ABS should work only when tire come to a lock condition. Now we can see how an ABS is the principle of operation of an ABS. The basic principle of the system is that wheel speed is monitored, that we have seen wheel speed has to be monitored via sensors. We have seen optical sensor by the electronic control unit, so that it can determine the point at which the wheel is about to skid and thus lose grip. So, it will determine, that is the wheel speed can be monitored, and by using that wheel speed or by monitoring that wheel speed we can check whether wheel is going to stop or not. When this point is reached, the control unit can reduce the brake pressure. At that time it will reduce the brake pressure, that is by it will withdraw the, it will reduce the pressure inside the hydraulic unit, and with the help of that we can reduce the brake. So, this is the ABS system of a bike, that is the ABS system of a bike. So, front wheel, this is the front wheel. So, here there is a speed sensor is there. So, this is the speed sensor, this black line is the speed sensing mechanism that is coming to the electronic control unit. You can see this black line is coming to this electronic control unit. For electronic control unit there should be a power supply and a battery is required. So, that is the battery. Electronic control unit, for working of any electronic device, a DC power supply is required. So, we are giving a battery to the electronic control unit, and the other input to the electronic control unit is from the speed sensor, and you can see the output of the electronic control unit. Two solenoid valves are there, two solenoid actuators are there, and the other output is to motor, that is for pumping this hydraulic fluid. There is a motor is there. So, here what will happen is, when you are applying the brake, so here there is a fluid will be stored here, and while you are applying the brake, what will happen is, so while applying the brake, the pressure inside this tube, hydraulic, this is a hydraulic braking system. All ABS system will have a hydraulic braking system. Without a hydraulic braking system, it will not work. Normally all ABS will work on a hydraulic brake system, and in almost all vehicles nowadays we are using hydraulic brake system itself. So, while applying this, what will happen, in this tube, through this tube, the pressure inside this tube is increased, and because of that increase in pressure it will apply brake. So, this is a disc brake system. Disc brake system is actually an external braking system. We are applying the brake outside this disc. You can see in some vehicles it is drum brake. Drum brake is an internal braking system. Both are based on friction mechanism. Internal drum brake system as well as disc brake system, both are based on friction mechanism. Here there will be some pads will be there, so that pads will come to close and it will make the bike stationary. So, here when you are applying the brake, the pressure inside this tube will be increased, and suppose the tire comes to rest. What will happen? It will be sensed through this line. So, at that time what will happen? It knows it has to reduce the pressure inside the tube. So, what will happen? To reduce the pressure inside the tube, there is a valve known as isolation valve. This is a valve. So, there is a solenoid, and it will push this valve down. You can see in the next slide. It will push the valve down. So, what will happen? This is separated. Hydraulic line is separated. So, the pressure inside, this is coming through this, and as this is separated, but this is there, this line is there. Here, from here only it is cut. The fluid is there. All these are hydraulic lines, and here there is a non-return valve is also there. Non-return valve means it will have movement in this direction only. So, isolation valve will isolate this brake pedal system and this tire, the hydraulic part of the brake system and the tire system. So, there is an isolation. So, what will happen? So, because of that itself there can be a reduction in pressure. So, it will check, electronic control unit will check whether it is released or not. Sometimes it may be released or sometimes it may not be released. If it is released, what will happen? Then the tire will tire come to, if it is released, what will happen? Tire will go to rotation again, and again it may sometimes come to a rest, and again this action will comes again. Suppose if it is not released, even after the operation of the isolation valve, suppose even after the operation of the isolation valve, if it is not released, what will happen is there is another valve known as a dump valve. Dump valve will come to close. This will close the dump valve. This will close the dump valve, and it will pump. It will pump. This motor will pump the fluid inside this tube towards back. That is, it will pump this to this tube. So, because of that, what will happen? Because of that pumping of this motor, this is a hydraulic motor. Hydraulic motor is actually electric, but we are using it to pump this hydraulic fluid. That is, we are using this motor to pump this hydraulic fluid. So, because of that pumping, what will happen is it will reduce the pressure inside this yellow line. So, again because of that tire may reduce, tire may rotate again. So, again electronic control unit will senses, the speed is sensed. So, this mechanism will happen, and there is a low pressure accumulator is there, low pressure accumulator. So, low pressure accumulator means actually accumulate, similar to our microcontroller accumulator. It will accumulate the excess fluid in this tube, hydraulic tube, in this LPA, low pressure accumulator. These are the parts of a hydraulic control unit. So, the parts of a hydraulic control units are an electronic control unit, a hydraulic control unit or hydraulic modulator, again a motor. All these are the parts of a hydraulic control unit. So, this apply cycle continues many times a second, normally more than 10 times a second, individually at each wheel. In each wheel this will happen. That is, in each wheel means for each wheel there will be a hydraulic control unit and electronic control unit. All these things will be there until the driver releases the brake pedal. The driver, it will happen till the driver releases the brake pedal or the vehicle speed is reduced to approximately walking pace, whereby ABS system then deactivates automatically. That is, this system will work until the ABS system will come to a automatic deactivation. This allows the vehicle can come to a complete halt. This process of apply release, apply based on sensor signal is a good example of a closed loop control system. So, this is a very good example. ABS is a very good example of a closed loop control system. The hydraulic modulator or hydraulic control unit, this is here it is mentioned as hydraulic modulator, which is same as hydraulic control unit. Hydraulic modulator assembly consists of a number of solenoid valves that we have seen here. We have seen here a number of solenoid valves. So here these are solenoid valves. A number of solenoid valves consists of a number of solenoid valves that can open or close the hydraulic circuit between master cylinder, brake cylinders and return pump. So, because of this solenoid valve, that is we have seen a non-return valve, an isolation valve, a dump valve. These two are the solenoid valves. So, by the action of these valves, we can control the flow of fluid inside this tube. So, that is actually mentioned here. The hydraulic modulator assembly consists of a number of solenoid valves that can open or close the hydraulic circuits between master cylinder, brake cylinder and return pump. The return pump controls the pressure release and returns fluid to the master cylinder from the brake cylinder during the pressure reduction phase. That is, there will be an isolation, we have seen an isolation valve. So, it will separate this pressure in the tube, in different parts of the tube. Generally, a pair of valves are allocated for each wheel hydraulic brake unit. We have seen two valves are there. One is dump valve and the other is isolation valve. So, these for these valves, a solenoid, two solenoids are two solenoid valves are required. So, a pair of valves are allocated for each wheel. For each wheel, a hydraulic for each wheel, two pair of valves are required. A pair, not two pair, a single pair of valves are required. All of these components are often contained within the modulator assembly, complete with the ECU electronics. All these will come in the ECU. All these things will come in the ECU and hydraulic unit. ECU is different and hydraulic unit is different. So, what are the inputs to the electronic control unit? We have seen the input to the electronic control unit is the wheel speed and the acceleration status. The wheel speed and acceleration status. And the wheel speed sensors can be passive or active. No, it can be optical also. It can be passive or active, or Hall effect sensor also can be used. They are incremental. They are incremental rotation sensors that produce analog or digital signals for processing via ECU to determine instantaneous wheel speed. So, instantaneous wheel speed has to be determined from this wheel speed sensor. Normally, it can be a non-contact sensor such as Hall effect sensor or optical sensor. A vehicle is normally fitted with one sensor per wheel. That is, each sensor has each wheel has got a sensor. The ABS ECU evaluates the signal from the wheel speed sensors. That is, ABS ECU. ECU will evaluate the signal from each wheel speed sensors. From these signals, the acceleration or deceleration of the wheel, brake slip, wheel reference speed and vehicle speed can be derived. All these can be derived from our ECU. Once the speed is received in the ECU, ECU means electronic control unit. The control is by electronic methods. So, by receiving that information, ECU will determine what to do. This information is processed by a microcontroller. ECU means ECU consists of microcontroller, and the necessary reactions are calculated and sent to the hydraulic modulator via the output stage as the control signal or valves and pump that we have seen here. That is, ECU got the input. ECU got the input from here through this blue line. Then ECU gives the output through these lines. It will decide whether the motor has to pump. It will decide whether the isolation valve has to work. It will decide whether the dump valve has to work. All these things are decided by the ECU depending upon the only one input is the speed of the wheel. Only one input is the speed of the wheel. The main parts of an ECU are input stage. Input stage consists of filters, timers, counter that receive and condition the wheel speed sensor signal ready for further processing and calculation in the ECU. That is, there should be some filter. That is, there should be any error in the speed of the wheel. Then the other is the processing unit. That is, it is a microcontroller that you know. In every ECU there will be a decision making device is there. That is our microprocessor or microcontroller. A microcontroller evaluates the signal from the wheel speed sensor and compares them with the reference values. Using sophisticated control algorithms, the ECU calculates the desired reaction needed and sends this data to the actuator. Actuator, what is the actuator? Or solenoid valve and motor. Two solenoid valves we have seen. That is, one is our dump valve and another is isolation valve. and there is a hydraulic motor is also there, hydraulic pump is also there. So these are the actuator, to actuator it will give the output. Then power stage means every electronic device needs a battery or a DC supply. So the power stage is from a battery. Again there is a monitoring unit, there is a monitoring circuit that continuously checks that the ABS system is functioning correctly. That is, while turning on the vehicle itself, we can check there will be a indication in the dashboard whether the ABS is fault or not. If a fault is detected, the ABS feature is switched off and the driver is warned by a dashboard indicator. That is, there will be a warning mechanism in the dashboard indicator. So normal, even if ABS is not working, there will be a normal braking function will be there. That is, if there is no ABS, there is no problem in moving the vehicle at a slow speed. Even without ABS, you can move the vehicle. That is, you cannot go at a higher speed. That is, in any case, the translation velocity should not be higher than the rotational velocity, or it should not be in different direction. That is, in that case there can be accident. So their translation velocity is higher means the velocity of the vehicle is higher. So there is no problem in running the vehicle at a normal speed even without ABS.